Hello and welcome to EE233. I'm your TA, Blake Wingard, and in this video we'll be looking at the factorial functions for our numerical library. And so just starting out, we need to know what a factorial is. And to help you out, I have included the Wikipedia link. And so as you see, the definition for factorial is that it is the product of all positive integers from n to minus 1. For example, they've given us here that 5 factorial is 5 times 4 times 3 times 2 times 1, which gives us 120. The only minor exception here is that we also have the factorial of 0, which is 1. Okay, so if we come in here to our code, we should go ahead and start thinking about our switches. And so just right off the bat, we know that the argv0 is and always will be the program's name. Then we have argv1, and we're going to keep consistency with the others by calling it our function selection. And then we will use argv2 as the input for n. Okay. So let's get a couple variables in here, our input variable n and our output variable results. Notice that for the factorial functions I have used double. The reason being is that as you hit, say, factorial of 25, you've already gone beyond the range of the largest integer type we have in C. Unsigned long int cannot hold this value, and likewise none of these larger values. But double can. Alright, so if we start typing out our switches, we know we should have an argument count of 3, and then we will check our argv1 for the functions selected. To keep consistency, we're just going to use / with the function name. Alright, and if they match, this should return 0. Notice I'm using string compare I to keep the case insensitive. And what are our steps at this point? Well, we should be capturing the input, and we will store that in n. Then we should call the function, in this case factorial v1, and we should print the results. Alright, so let's fill in the steps. In order to capture the results in, we're just going to use our atoy function, array to integer, on argv2. Then we will call our factorial function with n. And as for the results, we're going to keep this straightforward, a printf utilizing the function name with input, which is an integer, then the output, which is a double. So our input is n, output results. Okay. And then getting v2 set up is just a copy and paste away, plus a few edits, changing v1s to v2s. Make sure you get all of them. And then let's go ahead and, provided they enter something in wrong, print out the help, and let's go ahead and tell them that there was an invalid argument. Whether it's they didn't have enough or didn't enter it in right, that's up to them to identify. Go ahead and fill in your help. So we have our usages. Let's go ahead and get that. Okay, so we know it should have the program's name, which is numerical_demo.exe. Then we have /, factorial underscore v1. And for the example, let's go ahead and use 5 because we know what that's supposed to be. And then let's get our v2 in there. As for the number we use, let's go ahead and use 0, as that's kind of our edge case, you could say. And what I always like to do when I'm first setting up my switches is include some kind of printf in the function to tell me that I have entered the correct function. Because the last thing you want to do is go through all this trouble of writing switches and end up calling the wrong function. So v1 and v2. Let's build it. Then come on to your command line. Navigate to your project folder all the way down to your executable. Because of my long path name, we'll just increase the length a bit. And there you go. So let's test it without any arguments. We should get our help. Cool. And then let's take this, copy, paste. And so if we use v1, we should see that we enter our v1 function. Great. And v2 should enter our v2. All right. So now let's write our function. So what we know about the factorial is that we start it in, we multiply the current value with 1 less of the previous, or 1 less of the previous n used to help keep a distinction. And we will stop before 0. All right. So we should have at least one variable. That would be our results, which we will return at some point. And then for the sake of this program, I'm going to use a temporary variable as opposed to just changing the n. The reasons will become clear when we write our v2. So for the v1, the only condition we have with the factorial is that we must use a while loop. Okay? But before we get into that, we do need to handle our errors and edge cases. So one error is that they enter a value that is negative. So if n is less than 0, that's an error. N must be non-negative. And I always like to say, or at least tell the user what n or what value they actually entered. Print out the help, and we'll set the results to some kind of error value like -1, just to alert the program calling the function that something went wrong. Our next edge case is when n is equal to 0, in which case we simply set results equal to 1. Okay, so let's go ahead and get that in there. So we know we should start at n, so let's get our temporary variable starting at n. Then multiply the current with 1 less of the previous n used. Perhaps it could use a little refining in the way it's phrased, but effectively we could look at that as taking whatever the current value of results is and multiplying it times n. And then after that, subtracting 1 from n. For those that don't know, n minus minus is the same as n is equal to n minus 1. Now, with all that said, I did promise I was going to use a temporary variable. So let's go ahead and make sure you change those n's to temp_n. The only thing that's left is we need to be repeating this and stop before 0. That is a while loop. So we should stop before 0, or better yet, we should keep doing this while the temporary n is greater than 0. Alright, looks pretty good. Only thing left to do is to build and test. So based on the example we saw earlier, if we built it right, this should return 120. Oops, made a little mistake. I forgot to initialize the results. The results should start at some value that makes sense, and in this case it should be 1, because 1 times anything will be itself, so it doesn't affect our factorial value. Let's try that again. There we go. Everything is right with the program. Okay. And then let's go ahead and test our edge case 0. As you can see, that's 1. And then let's test our error -1. Error n must be non-negative. N was -1. And then it prints out our help, returns a proper error value. So that all looks good. I could declare this function as done. So then let's go ahead and comment out the function name to indicate to us that we're done with it. And then let's take this code, copy it down here. I'm going to go ahead and at least have the commented name match, just so it doesn't look like all we did was copy and paste. So for the v2, we have to use a for loop. So how do we change the while loop into a for loop? Well, we know that with a for loop, the first step is the step that happens before the while loop. Or taking a step back, it's the first thing that happens before we enter the loop. The second thing that we do is the condition, which is the same here inside the loop. Boom. And then the last part is what occurs after each cycle. So if we think about it for a bit, we know we want to start with our temporary n being equal to n. And then for each cycle, we want to subtract 1 from the temporary n. The steps we're doing, same as before with the while loop. As a matter of fact, let's make this a little more interesting and use a bit more convenient syntax, such as results times equal temp_n, which is the same as the part I just commented out. And then, just so we can keep it around for reference, let's go ahead and comment out this while loop. Let's build it. And let's test v2. So provided everything is working, we should get the same results from v2 that we got from v1. Factorial of 5 is 120. The factorial of 0 is 1. And the factorial of -1 is an error. And that concludes the factorial videos. If you have any questions, please feel free to reach out to your professor. I hope you found this video helpful, and thanks for watching.